Welcome anybody. Well, I enjoyed this video a little bit. It was kind of an interesting eye-opener. Don't know a lot about C programming language, to tell you the truth. And I see that, ultimately if you want to send an array into a function, you need to send another parameter indicating the number of elements. So then I thought, well, how does this same example work in assembly? What do you got to do? What happens? And I'll tell you right now, this compiler does not allow buffers on the stack. It's kind of one of the rules of operation I got going here, and until I find out that it's too strict a rule, I'll just keep going with it. So the array will not be passed as a buffer onto the stack. The compiler will be passing it as a pointer as well. So we're going to see how that all gets handled here. So to start off, what I have is a console window. Here's my basic template. If I were to run that, see it says press enter, and that's it. So it does not really have an entry point. So I'm going to make one. Called function main. No parameters. And I'm going to make a local variable. Now because local variables are on the stack, the compiler will not let me make a buffer on the stack. Well, let's try for a second, see what happens. Let's make a local DD. DD is the data type for 4 bytes. Times 5 elements, named by array. If I do a preview on that, it says this compiler version will not store buffers on the stack. You may, however, add the keyword data or indata and have a static buffer that is dedicated just for this function. So essentially, if I put the word data here, it's going to be storing this buffer in the data section. This will be in program space, non-allocated on the heap, a buffer in the data section that's dedicated to this function main. Okay, so what are we going to do here? Let's do invoke console.code.writeLine. We're going to write some things to the console window, like address. So the drop down shows these properties that the compiler's generated for the buffer. It has an address, has a quantity used, and size. So we're just gonna echo all these out just so we can kind of see what they are. Invoke console.code.writeLine quantity quantity console.code.writeLine used used, and that's it for now. Let's see what the preview says about that. Okay, they liked it. Let's go for a compile. We're not done yet, but I'm going to just kind of run what we have so far and see what we got. Okay, address 32180. That's program space. Size 4. That's an element size. DD is 4. It's not the size of the array, it's the size of an element. Quantity 5. That means there's 5 elements in the buffer. Quantity used 0. So it's when buffers by default, there's nothing in them. Quantity and quantity used is kind of two variables that the programmer gets to use. You'll be able to read and write to that. Although if you write to the quantity field something that's not the real quantity, you could create problems. That's a good point. I don't know if there's security there to stop you from writing to the quantity field. I don't think there is. This is assembly. You can do whatever you want. So anyway, let's print a blank line in the console window. And let's make some blank lines under here. Let's make a function called client. And the function takes a parameter. It's a DD with properties. Now, you have to say with properties because that means the function requires it to be a buffer variable. The properties are quantity and quantity used. They're actually located right before the array. It's two 8-byte numbers called quantity and quantity used. If you don't have the with properties written there, then the function will be expecting just one variable. Named, now I could say my array here, but I'm going to say called his array. Just to kind of make it, to prove that it's not going to be using the same variable name. Okay. Invoke client with my array. Okay, you see there's some parts there that are red. Didn't like my array, doesn't exist in the function. It's called his array. Whoa. Keyboard's a little sticky. His array. Now, there is an extra property here that was not here before. I'm going to take a look at what that is. I'm going to print it right here. So when I pull up the IntelliSense for his array, it has the original ones plus the new one is called address pointed at. Because his array is actually a pointer to an array. Let's run that. Let's do a preview, see what that looks good. Let's do a compile. And let's do a run. So you see the address 32180. Size 4, quantity 5, quantity used 0. See the address when it's inside the function is 18FF18. Now that's a stack address, by the way. Address pointed at is 32180, which is the original address of the original data. Size is 4, quantity 5, quantity used 0. Same. There it is. So the compiler will not pass an array as a buffer on the stack. No stack buffers. And I'm doing that on purpose because I'd like to try to make a compiler that has less chances for stack buffer overflows. If you don't have stack buffers on your stack ever, or objects are ever on the stack, then it kind of reduces the chances of ever having a stack overflow. Buffer overrun, buffer underrun, all those things. It passes a pointer. The quantity and quantity used are two properties of the array that are actually embedded in the data and tucked away hidden before the array. And that passes as well. And it just works. And it, you don't have to have an extra parameter saying, how big the array is. That's all I got for today. Thanks for watching.